Okay, question 19 is a true-false question. So you have to find whether a certain statement is true or false. Now, true and false questions can be tough because it's particularly for question 19 on your exam, because you really have to know your facts straight. Okay. So some of the facts that involve is domain and range of a trig ratio. This question obviously is going to involve some trig. Mean value theorem, continuity, and I put down first derivative test here because you have to know what it means for the function to be increasing and decreasing, and it involves the first derivative, right? So let's go to the solution now.
Okay, f is differentiable at such that when you put 2 in you get 6, and for all values of x the slope ranges from 1 to 4. Now, first of all, the derivative exists for all values of x, which means the domain of the f at x, y equals f at x, is everything. Okay, so the normal function is continuous everywhere also. Okay, let's analyze the first statement. The function is continuous everywhere. Okay, so the only place that it would be not continuous is if the bottom is equal to 0. However, sine of x and cosine of x ranges from -1 and 1. So the product, right? Actually, using a double angle formula, this is equal to half of sine of 2x. You can see it will range from half to minus half. So if you do a 2 minus any number between half and minus half, it will never equal to 0. Okay, so the top is always continuous. The bottom can never equal 2, right? So 2, this will range from 2 plus half, which is 5 over 2, and 2 minus half, which is 3 over 2. Okay, it will never be negative. And numerator is always always continuous everywhere, so this statement is true. Okay, it is continuous everywhere for all real values of x. Okay, for the second statement, we want to test if this is always increasing, then we need to show that the derivative is always positive. Let's differentiate that first. The 3 will come down, will give you x squared minus 2x plus f prime at x. Okay, so x squared minus 2x, that's a quadratic. Now I want to make sure this is always positive. So I want to know what the minimum, I know this is it's a part of a parabola, it's increasing, but what is the minimum value of x squared minus 2x? So we can figure that out if you complete the square. So we get this. So this minimum value is -1. Okay, that's the smallest you can possibly get. Now this minimum value is actually it's bigger than 1, right? That's what it says. So the smallest you can get is -1, and this is always bigger than 1. If you add these two, clearly it's always going to be positive, right? Smallest you can get is -1 again. This is the smallest possible value is still bigger than 1. So it's going to be some small number that's positive. It's always positive. So I've just shown that h prime is always positive. Therefore, it's always increasing. Okay, so this statement is also true. Okay, to figure out the truth of this last statement, we got to use this definition right here. Okay, so it's sort of the mean value theorem. To find out what f at 5 ranges from, right, f at 2 is given. So I'm going to subtract -5 minus 2. And we know that this has to be between 1 and 4. So once again, I use f at 2 just because it was given. Okay, so I get f at 5 minus 6 all over 3. It ranges from 1 to 4. So f at 5 minus 6 ranges from 12, 3. So add everything by 6, you get 9 and 18. Okay, so this is also true. Hence, all three statements are true.